Hi Advik, what are you doing in school, Advik, in pre-calc?
Ma, if my mouth is set on fire, you are cooking.
We just started to graph like sine curves and cosine curves and like sinusoidal functions.
Oh wow. Okay.
Yes. Yes.
Let's wait, ma. Are you understanding what we are discussing on polar graphs?
Yeah, it just takes me like a second to understand, but once you do questions, I understand them. Like last week's class, I understood pretty well.
You are writing the pre-calc, AP pre-calc this year, right, Advik?
Yeah.
And next year, what are you taking?
Calc A, B, B, C.
AB and BC, huh?
Yeah.
Dhwani, what are you taking next year, ma?
I'm taking Calc AB.
AB, okay. Parvini, you?
I'm also taking Calc AB.
Lopa, okay, I asked you. Okay, let's move ahead then. Let the others come. So we'll do the polar graphs, rest of it. What, Parvini, you're done with polar graphs at school? You've started vectors?
Yeah, we started vectors.
Is that easy?
Yeah, it's pretty easy.
Yeah, I thought of discussing a little bit on vectors and then going to go ahead with the polar graphs. Make sense? That way everybody finds it useful. Okay, let me get you a little bit on vectors and then I'll move on to vectors will be very intro level. A couple of things we need to understand. Basically, have you heard of the term vector? Let me get started with vectors. Okay, the topic vectors is very simple, but then an intro is given, but that's not a part of the exam, meaning they don't quiz you on any of the vector topics for the exam. Okay, what we are going to deal with is vectors introduction today. Additionally, I'll go ahead with the polar graphs. Shragvi, what are you doing in school, ma Shragvi?
We're doing like complex numbers.
Okay, okay. Complex numbers, rectangular to polar form, polar to rectangular form, are you doing?
Yeah.
Okay, nice. The plan for me for today is to introduce you to vectors and then I'll move on to polar graphing. Okay, I'll continue with vectors little later if needed. Okay, so to start with, have you heard of the term vector and scalar? Vector, scalar. What is a vector? Vector is basically a directed line segment. That means what? This one A, B, it has a direction. This means A, B. A is your starting point, B goes on forever. Suppose if you say BA, B is your starting point, it goes. So it has a direction and a magnitude. What is a magnitude? Magnitude plus direction. So I can call this line segment 3 units, that is the magnitude. The number is the magnitude and it has a direction. Okay, direction will be given in terms of theta. Scalar means it's just the magnitude. The number 3 is a scalar. See what I mean? Whereas this one has magnitude and direction. Scalar is just a number. It has just got magnitude to it. Okay, can I move on? Now, these are the important principles of vector, meaning at least the important concepts that you need to get introduced to. That's the list in here. I'll get it up and running on the board. Do you see it? So here it's basically a directed line segment. If you write it like this is vector V. Okay. Usually, how do you write? I said this has a magnitude, this has a direction, right? So I will write the magnitude like this. Okay, magnitude is always a number or it is a scalar quantity. Okay, now direction is always expressed in theta. Theta, the base to calculate the angle is always the x-axis. Meaning, suppose there is a vector like this. You project the x-axis, this is your theta. Makes sense? So this is the magnitude, the length of it is the magnitude. Suppose if I have this vector, so what is the theta in here? We project the x-axis, from the x-axis this is my theta. Any questions? Manav, to get you up to speed, we have just started discussing vectors, just an intro to vectors, and then I will continue with the polar graphing that we were doing. Makes sense, Manav?
Yeah.
What are you doing in school, Manav?
Law of sines and cosines.
Oh, law of sines and cosines. Easy, right?
Yeah.
Okay. Do you remember what we have discussed in law of sines and cosines before? No.
I don't think we did it.
As a part of geometry, we didn't do?
I don't remember. I may have done it, but I don't remember.
I see. Are you going to cover vectors at school? Do you know?
I think we'll do it later, like next
Okay.
week or 2 weeks.
Okay. So here, what is this component form of vector? Component form of vector, we'll discuss as we move forward. So usually, if this is x, okay, this is the y-axis, right? Suppose if a vector is like this, right? Now this will be called as your y. So this will be called as your magnitude of the vector. So for the magnitude of the vector, what you do? Magnitude of the vector is Pythagorean theorem, x square plus y square. How do you find theta? Theta will be tan inverse of y by x. Any questions there? Okay. Let's see this one. Vector is an easy topic provided you get a hang of it. Let's see. Okay, other important things. A vector whose magnitude is 1. Vector whose magnitude is 1 is called a unit vector. Magnitude equal to 1, where this is equal to 1 is called a unit vector. Now, what is I? You know, right? Meaning in vector terms, right? I is a vector. I denotes a vector with angle 0. Okay. J denotes a vector with angle 90 degrees. Any questions? Any questions on this? These are just things that we assume or we implicitly assume. Now let's say we always write, okay, let's say we have a vector like this. Suppose we have a vector like this. Suppose we have a vector like this. This is my vector AB. How do you write this vector? AB will be equal to 2i plus 3j. Does that make sense? 2i plus 3j. X, y. Makes sense, guys? We always write it as a sum of the two. I plus 2. Now let's go ahead. Let's try this one. How about this? Suppose I give you two vectors. Okay. I'm going to ask for a couple of things. First, let me do, and then you can do by yourselves too. But this will not be assessed as a part of AP Pre-Calc. Okay. The exam, College Board is not going to ask you questions and vectors. However, a knowledge on vectors is really useful. Now, V equal to 2I plus 3j. W will be equal to I minus 4j. Now, if they ask for magnitude of vector V, how will we calculate? What is the magnitude of vector V? Any questions? Any thoughts? You can tell, guys. Shagvi, would you be able to say? Shagvi, would you be able to say, ma?
I don't know.
We discussed, right? We discussed the magnitude of vectors, right? Okay, so maybe Parvini or Manav, you can tell as well. What is the magnitude of vector? See, here it is. Yeah, go ahead.
So you have to add the two x values
Uh-huh.
and square root them.
So how will you find that? 4 plus 9, right? Don't worry about the I and the j. But you're going to, this is the x value, this is the y value, right? So 4 plus 9 will be equal to square root of 13. Make sense?
Miss Priya, the I is like imaginary numbers or just the
No,
vertical?
that's what I'm saying. Meaning the horizontal component is indicated by that. The vertical component is indicated by the j. See, if you want to write the component form of the vector, you say 2i, 3j. That is how you indicate vectors. This represents the I represents the x part of it, j represents the y part of it. Make sense?
Yes.
Okay. Now let's go ahead and try. If I ask you 3v minus 2w, what does it mean? 3 times vector v minus 2 times vector w. 3 is just a scalar, right? It's very easy to multiply that. 2i plus 3j minus 2 times I minus 4j. So what do we do here? 6i plus 9j minus 2i plus 8j. So you can combine these two, get 16, 17j. Make sense, guys? Scalar, see, this is the scalar multiplication of vectors. This is a vector. You're multiplying with a scalar. You just multiply the two. Akash, we are discussing vectors and we'll go to the continuation of polar graphs. You're also discussing sine and law of sines and cosines at school.
Yeah, we're doing that and vector. We're gonna start vectors.
Okay.
Miss Priya,
Yeah, ma.
at school they said not to distribute it with the negative sign.
Not to distribute, meaning?
Like just to distribute the 2 to the I and the minus 4j.
Then how will you combine, ma?
They said
Yeah,
not
yeah,
to do
absolutely fine. See, minus 2i, okay, and after that you have minus 8j. Then what happens when you want to subtract?
Then you do 6i minus 2i and
Same thing, right? You distribute it, right?
oh yeah.
Yeah. The thing is, the teacher might have said just because you would not want to get confused when you distribute the minus 2, right? Most of you will make a mistake here. So they would have said just distribute this and then apply the minus. Make sense?
Yeah.
Okay. So now let's go ahead and try 2w minus v. For this one, can we try 2w minus v? What is the answer? This is operations on vectors.
Wait, Miss Priya,
Yeah, ma?
I'm a bit confused on I and J.
Okay, tell me, what is that you're
What
confused on?
does what exactly does I and J mean?
See, here
Guys, my
X co-
space overloaded.
Wait, check it
Can
out.
I watch something?
Yeah.
With that guy?
Chakra. Yeah. See, any vector has two components, okay? The x component and the y component. Instead of saying 2x, I is considered a vector that is at an angle of 0 with the x-axis. J is considered a vector that is at an angle of 90 degree with the x-axis. So, the x and y components of vector are indicated using the I and j. Okay. So 2i plus 3j means on a coordinate plane it indicates a vector 2i 3j. So the vector is like this, 2i 2i 3j, right? So that's the vector. Make sense?
Yeah.
Now if we want to find out 2w minus v, right? I'll go ahead and do this one. Next I'll ask you one more. 2w is I minus 4j minus v is 2i plus 3j. Here 2i minus 8j minus 2i minus 3j. So that will be 2i and minus 2i will get cancelled. It will end up with 11j. Any questions? Okay. How about, can we try u plus v? The magnitude of u plus v. Can we try that? Do you want to give the answers?
There's no value for you.
Miss Priya, there's
Sorry,
no
ma. Sorry, yes. V plus W. I meant to ask you V plus W. Shravya, I would like to get answers from you too.
Yeah, I sent you my last answer.
Sure. I'm checking. Yes, Shravya, you got it. Good job. Nice. See, when I ask for the magnitude, it will be, I'm asking for the magnitude, not just W plus V. W plus V will be a vector. But when I ask for the magnitude means, I'm asking for, the magnitude is written like this. If it is the absolute value, then I have to go ahead and do the x value, x square plus y square thing. So that is your magnitude. The theta of vector v, the angle of that vector is written as tan inverse of y by x. Okay, now I asked you just the magnitude, not just the sum of the vectors, but I asked you for the magnitude of the sum. So what did you guys get? Try, guys, I'll wait.
Like what?
Are you able to do?
They're saying infertility.
You get? Are you getting 8 of 10, Amma? Yes, that's right then. Akash, are you getting it, Akash?
Yeah, I'm trying to solve.
You're in pitch dark, right?
Yeah, but I'm
You're okay. I don't mind. Okay. Sri and Manav, you're not on the video. Dhwani is not on the video. I don't know. Left you guys. Did you get it?
it's all on.
Yeah, I can solve it on the board. You came a little late, Akash. Okay, so here. Manav, did you get it?
Yeah, I think I just gotta add the absolute value.
So how to do the absolute value? So first
Yeah.
you add the vectors, then you will have a vector after that, correct? So now this is going to be minus 2, I'm sorry, plus 3i, then minus j. That is your sum. Okay, but This is your sum. That means let's say w plus v equal to y. So that is the y vector. Okay. But when you write this vector in what is the component form of a vector? I want to tell you what is the component form of vector y. Suppose if they ask you component form of vector y, you use these symbols and say 3 comma minus 1. That is how you write the component form of the vector. So for this vector, the component form is 2 comma 3. For this, it is 1 comma minus 4. That's how you write the component form of vectors. Now, how do we write the magnitude of this? Magnitude of this is nothing but 3 square and then plus this is a minus 1 the whole square, right? So it will be 1. So it will be square root of 10. Any questions?
Wait, so when it says you find W and V, you add both the expressions, right? And then you equate it to Y, and then I'm confused how I got 3 and minus 1.
This is the sum, right? Sum is 3i minus j, right?
Yeah.
So what is
Oh,
this? This is 3, this is minus 1, right?
mhm.
So this we did discuss a little before. The magnitude of any vector is given by this. Okay, the angle of the vector is given by tan inverse of y value by x value. Tan inverse of minus 1 by 3. Make sense?
Mhm.
Okay. So let's see more, a little more maybe. Okay, how about this? Suppose if I am given this vector, okay, this is the vector that they have given, okay. The thing is here clearly which is the starting point. See, A indicates the starting point, B indicates the end, meaning that's the direction towards which the vector is moving. Okay, now how do I A B vector? How am I going to indicate it? Meaning, what is this vector A B? For A, usually I can call the A point. How can I call the A point? So I'll call it as 1 comma minus 3. Can I call like that? Yes. This B would be what? 1, 2, 3. Minus 3 comma 2. Any questions? Any questions on that?
Yeah,
Okay,
1
now.
comma minus 2.
Oh, did I make a mistake? Wait, sorry. 1 comma minus 2, ama. 1 comma minus 2. And then this is, am I doing it right? 1, 2, 3 comma 2. Correct. So now, how do I write AB? I have to write the vector AB. For that, okay, first let me write the vector in component form, meaning AB in component form. I would like to see how to write it in component form. Basically, it goes like this. Ending vector, see, minus 3 minus 1, 2 minus minus 2. Does that make sense? I start with B. Minus 3 minus 1, 2, I start here, minus minus 2. So that is A comma B vector. Then only you'll have the vector here. Minus 4 comma 4 is the component form of the vector. Otherwise, if I want to write the vector AB, I can write it out as minus 4i plus 4j. Make sense? Does that make sense? They give you a vector, ending point minus the starting point, ending point minus the starting point. Component form of the vector is given like this. This is the vector. What is the magnitude of the vector AB? That will be 16 plus 16, which is square root of 32, which is 4 root 2. Any questions?
Is I always related to the x value and j is related
Correct.
to
That is why I is considered a vector with theta 0, meaning indicates the x part. Y indicates the, j indicates the y part.
Okay.
Can I move on? Okay, that the first half you missed, Akash. Okay, so now let's try this one. Okay, what is the direction of this vector AB? What is the direction of this vector AB? Let's do this. I just erased it off. 1 comma minus 2. This was 1, 2, 3 comma 2, right? Minus 3 comma 2. Now AB vector was, I will write it down as minus 3. I'll start with the ending point minus 1i and then 2 minus 2j. So that will be minus 4i plus 4j, right? Now the magnitude of vector AB is given as 16 plus 16 square root of 32. Now theta will be equal to tan inverse of y by x. So that would be tan inverse of, sorry guys, tan inverse of, what is that? 4 by minus 4. Tan inverse of minus 1. What is the answer? Tan inverse of minus 1 is?
Negative pi over 4.
So then where will the, negative. Is it right? Yeah, negative pi by 4. Negative pi by 4 now.
So
It's not making sense. Hold on,
wait,
hold on.
when we say tan minus 1, is that to find the angle?
Yeah.
But how is there a line on angle?
Yeah, there is a
I mean,
problem. I don't think this is minus pi by 4. We need to check. Is it minus pi by 4?
Is it 7 pi over 4, Miss Priya?
It is 7 pi over 4. 7 pi over?
4.
No, I think it's supposed to be from negative pi over 2 to pi over 2.
Well, first of all, what is tan inverse of minus 1? It's, what is tan inverse of minus 1?
Negative pi over 4.
Yeah, in this case, it is in the second quadrant, right? See, in this case,
Miss Priya, how do we know it's in the second quadrant? And
no. See, x-axis. This is always the base
oh,
axis.
okay,
I've
that's what
told
you
you.
mean.
Yeah.
So wouldn't it
Meaning I
be
didn't. Yeah. So what is the
3 pi
value?
over 4? 3
What is
pi
it?
over
What
4?
is it?
3 pi over 4?
That's nice. It's 3 pi by 4.
Where'd you get the 4 and 4 over negative 4 from again?
This one, ma. This one.
Okay, I see.
Got it?
Yeah.
Okay, we'll do a little more on this. Meaning, I think I urged you to go a little faster. That we are getting confused. Let's see. How about this? Let's see. I want to give you more on this. Let's see. Just a minute. Give a minute, guys. I thought this was enough, but looks like it's not. Let's see. I'll go a little deep in this. This would be vectors, right? Yeah, pre-calc vectors. Yeah. Yeah, see, but before I go into this hard stuff on vectors, yeah, this is better. Yeah, there was a point when we studied ijk vectors. It was not limited to I and j. We studied ijk, three-dimensional vectors we studied in pre-calc. Now only I'm looking at our notes 2 years back. Interesting. We don't even study that, right? Sad. Let's see. Okay, let's see. Now, I don't want this complicated vectors. Hold on. Vectors. Vector remediation pack. Yeah, this is good. Okay. How about this? See, okay. Okay, let's see this one. A, B. Okay, let's try this one. If you don't know, let me help you guys. Do I have the answers for these? I don't know. I don't have the answers for these. That's sad. Okay, how about this? We'll do it ourselves. If point A is this, point B is this, AB has a magnitude of 72. What is the value of P? It's a good question. Let's see. You have it? Let's see, guys. Are you able to do, or do you want me to do? You have to tell me, please, guys. Yeah, we used to graph 3D vectors. Angle between two vectors. Yeah, dot product, cross product. We used to do a lot. Okay. Did you get it? What is the value? Dhwani, you got it, Amma? A. Shri, are you following Shri?
Yeah.
B is a point minus 2 comma P. What is AB? AB is a magnitude of square root of 73. So that will be equal to square root of 73 will be equal to AB, right? So minus 2 minus 5 the whole square plus P minus 3 the whole square. Square root of 73 will be equal to 9 plus P minus 3 the whole square. What happens here? 9 plus P square minus 2P plus 9, right? Yep. P square minus 2P plus 18. What did you guys get? Two minus 5, 3.
I got C.
You got C. Let's see. 2 minus 5 is plus 3. 3 square is 9. P minus 3 the whole square. Then how did you go about here?
I just plugged it in.
Oh, you just plugged it into P. Oh, here, minus 5 you plugged it into here. Very clever. Okay. But why don't we solve this? Okay, let's try plugging in. If I plug in minus 5, right? It would be minus 5 means 8 square 64 plus 9. Yeah, 73. Minus 5 is working out. Is 5 working out? 9 plus 4. No, that's not working out. Minus 11. 9 plus, if you have a minus 11, that's not working out. Minus 14 square. No. If you substitute 11, 11 minus 3 is 8 square. Yeah, that will work out. So minus 5 and 11. But I would like to solve this, ma'am. Let's see. Nice way. After getting this equation, you can plug in and find out if you have options. Okay, C is your answer. But let's try this one. 73 will be equal to okay, I'm squaring both sides, but I'm missing, just because I'm squaring, I'll miss a lot of it. That's really okay. Let me see. So 73 minus 9 is what? 64. So P minus 3 the whole square is 64. So P minus 3 is equal to plus or minus 8. P minus 3 equal to 8. P minus 3 equal to minus 8. P will be equal to 11. P will be equal to a minus 5. See? That also works, guys. Did you get it? After this, you square both sides. When you square both sides, 73 will be equal to 9 plus p minus 3 the whole square. Then p minus 3 the whole square equal to 64, p equal to plus or p minus 3 equal to plus or minus 8. Solve that and get the answer. Make sense? Okay, we'll do a few problems of this sort. Let me give you this. I really want you to. Okay, how about this? This one is a good one. Okay, you're going to find everything. Okay, component form of vector v, you're going to write the vector as a vector. First write the vector as a vector, then find the component form of the vector, then find the magnitude of the vector, and find the angle of the vector. Everything you find out for this one. Can you try, guys? I really would like to have answers from everybody. Krish, are you following?
Yeah. Did you get it? I really want the vector AB in vector form. Okay, in vector form. Write it in vector form. Write it in component form. This means you will write it out as AI plus BJ, like that. Okay, then AB in component form. Then you will write it out as A comma B. Then I want you to write out what? Yeah, the magnitude of AB. And then I want the angle for the vector. We'll go to, I really feel we should go to polar graphs. Otherwise, this will take the full of the class. Did you get it, guys? I want to explain some graph forms of vectors as well.
Miss Priya, can we use the calculator to find the tan inverse?
Absolutely. Thanks for asking. Yes, you can. Tan inverse, if it's hard, yeah, this is hard actually.
Yeah, because I'm getting like
Correct,
negative 5 over 4, so I don't really know that.
Correct.
Is my answer correct?
I checked only Dhwani's. I'm sorry, 1 minute.
Answer correct?
Correct, Amma. 2 square root of 41 minus 51. Akash.
Yeah.
The magnitude form of the vector, okay. This you got it out as, okay. The in vector form you all got it as 8 minus 10j. That is the vector form, 8i minus 10j, right? 8i minus 10j, I'm assuming you all got. Now the component form is 8 comma minus 10. Advik, did you get it?
Yeah.
So this would be 64 plus 100, 164, right? So now you get a 41 out. Okay, so that would be 2 square root of 41, right, ma, Akash?
That's what I put.
Oh, what is that minus 51?
That's the angle.
Oh, it's the angle. I'm sorry, Akash. Okay.
Correct, but you have rounded it, right, to the nearest integer
I
and
just,
things,
yeah,
right?
I just rounded.
Yeah.
Miss Priya, for the tan inverse, like I got a negative number, so I just have 3.14, right?
Come again, Dhoni, what was your question?
Like I got a negative tan number, so it's like not technically on the graph. Like so, I added 3.14.
It is on the graph, right? Meaning it will be like this, right, Dhoni? This will be your vector.
So, oh, okay, I see.
Let's try. You bring up a good point. Let's try. So the vector is minus 3 comma 6 minus 3 comma 6. Let's try ma. Minus 3 comma 6 5 comma minus 4. See 5 comma minus 4. So it's somewhere here. So that's right, Madhwani. It will be minus 51.3 something. So that's right, because negative from the x. So this is its x-axis, right? So it's right. Makes
How'd you
sense?
get negative 51?
50. I'm sorry, Manav. The mistake you made is your mode is incorrect, Manav.
It's supposed to be in degrees.
It must be in. Usually, yes. They will
Miss Priya,
tell
I got
you.
negative 0.89.
See, that's the problem. You guys are calculating it in radians.
Should we do it in degrees?
Usually, yes, but they will tell you. If they don't tell, then please do it in degrees.
Oh, because usually like when we do this stuff, it's radians.
I'm with you. I should have told you.
Okay.
It is in degrees. The thing is here, see, we don't express it as negative angles, right? So the best way to express this is, yes, I know that this is minus 51.3, but left to me, I would want it in this angle, right? This is always your angle with respect to your x-axis, right? So what I would do, 360 minus 51.3. Whatever that is, I will write that as your theta. Make sense?
Oh, yeah.
Yeah. So always with respect to the x-axis, what you would express vector angles. Okay. They don't ask to express it in theta or whatever your teacher says. Now, there's a lot more to this, okay, to vectors. We will deal with it, but I just wanted to give an introduction on vectors. The main thing for me, one more important thing that I want to cover in vectors is graphical vectors, okay. Let's say, before I go to graphical vectors, right, vectors in graphs, right. Now, see here, this is basically a vector. A plane, let's consider this. See, it's vectors have a lot of practical applications. Plane, right? Pilot should know a lot about vectors. A plane is flying in the direction 15 degree west of north. What is this 15 degree west of north? North is this. 15 degree west of north is what? What is actual degree? 15 degree west of north is what? This is 15 degree east of north, right? This is 15 degree west of north. Am I making sense? So what is the actual degree, guys? What is the angle for this vector? The magnitude of that vector is magnitude. Let's say V is the vector, okay? Magnitude of that vector is 500. But what is the angle of the vector? Who can tell me? Who can tell me the actual angle of the vector? What is the angle of the vector? Angle starts with respect to x-axis. So what is the angle of the vector?
In my school, we learned this as headings and bearings. We learned it differently.
I did not come to bearings. That's the deal. Akash, repeat, Akash. What was that?
Yeah, but is this like the same concept?
Yeah. Basically, what is a bearing will come. Okay, it is the angle that's measured clockwise from north, but the bearing is not the angle, right? You see what I mean? Huh? See here, okay, here instead of giving this, they can ask you sometimes a plane is flying at a bearing of, okay, I'll come there, Akash. First, let's do this one. Meaning, a plane is flying in the direction of 15 degree. This is north, okay. 15 degree west of north is, this is west east, right? South. 15 degree west of north is this, right? But that's not the angle of the vector. The vector angle should always be calculated from x. So it will be 90 plus 15. Does that make sense? So that will be 500. 500 will be the magnitude of the vector. Okay, and the angle of the vector would be 90 plus 15. Does that make sense? 105 degrees. Make sense?
How is the vector 500?
We are only indicating the velocity vector, right, Amma?
Oh, so
Okay.
so in some cases velocity is same as the vector?
See, here we are indicating, meaning this one, right? So basically this is flying at 500 miles per hour at this angle. Okay, so the velocity vector is given by this vector.
Oh.
Okay, so the magnitude is 500 and the angle is this. Make sense?
Yeah.
Okay, now the same question, we introduce a new term called the bearing. Okay, when they refer to bearing in vectors, right, it is always the angle measured clockwise from north. Okay, so instead of this, they can give you a plane is flying at a bearing of 15 degrees. That means what? The plane, where is the plane flying? This is the north, south, east, west. Bearing indicates angle measured clockwise from north. Clockwise from north, it is flying at 15 degrees. Plane is flying in this direction, that's what they mean. Okay, with a velocity of 500 mile per hour means this vector can be indicated as 500. Then what is the angle? 500 is its magnitude, but the angle is 90 plus 15, 105. When you think about it, right, how do you write the x and y coordinate? X and y of meaning this particular vector has its own meaning. This is a vector, but it has the x component and the y component. So if you construct a right angle, right? So for this vector, let's say v, this is the x component. How do you write that x component? 500 cos 135. You know why? Because this is, okay, let's say this is your angle theta. This is your angle theta. Let's say there is a vector r. Okay. Now, this is your y value, this is your x value. Okay. From here, do you see cos theta will be equal to x by r. So, the x component, any vector can be split into its x component and the y component. So, x component of the vector is given by r cos theta. The vertical component, any vector, any directional vector, vector itself has a direction. So, this directed line segment can be split into two components. One is the x component, one is the y component, because if you can write sin theta will be equal to y by r, y equal to r sin theta, right? So, here this is the vertical component of the vector, this is the horizontal, y is the vertical component, x is the horizontal component of the vector. Any questions, guys? Any questions? Any questions? So here it is 500 cos 105, right? Now that is the x component. Y component of the vector is 500 sin 105. You have to put it in the calculator, write the values. So that is the vector. Okay, in component form you can write it like that. Let's see one more. This you're going to write, okay? I just need the decimal values, okay? You're going to write, I am just going to give you the question. You're going to get me the component form of this vector. A plane is on a bearing of 200 degrees, traveling at 450 miles per hour. Express the velocity of the plane as a vector in component form. I should have written in component form. I would like to see the vector in component form. Can we try? Please put it out in decimals. Tell me.
Is this in degrees again?
Yes, ma, it is in degrees. Why that question is coming, I'm wondering.
Degrees or radians? Like, that's what
Why?
I'm at.
See here. What is this?
Degrees.
Yeah, that itself will tell you. Do you get it? Would like to see your answers, guys. I got several answers. Let me check them out. Ah, really, ma? I am a little off now.
My answer is wrong. I just realized I took the miles per hour from the previous question instead of this.
Oh, okay. Parvini, is that right, ma?
I haven't sent my answers yet, Miss
Oh,
Priya.
okay.
Miss, where's my answer right now?
I will check. You have just interchanged both. Did you?
No, I put the one that I did cosine first, and then I put y as my sine.
I'm a little lost though. Okay, let's check. First of all, the sign also is a little a mess. Yeah, Manav, that's right.
Advik, are you getting the answers? Akash, are you getting the answers?
I'm almost done.
Shri, if it is at a bearing of 200, na, where it is flying, bearing means clockwise, right? So somewhere here it's flying, right, ma?
Oh, I think I know what I did. Wait 1 second.
Yeah, so basically it is, this is 200, then this 90 gets added. So I would do 450 cos 200 degrees. And then 450 sine. Manav, did you do that?
Wait, shouldn't it
Yeah.
be 290 degrees?
Yes, yes, ma'am.
That's what I did, and that's how I got my numbers.
450 cos 290 you did?
Yeah, that's what the numbers I got.
Let me do it instead. 450 cos 290. 450 cos 290 is 253. 450 cos. Did you put it in the degree mode?
Yeah, it's in degrees. I can show you my screen, but like.
Yeah, please.
Oh, okay.
Wait, let me see. Something is wrong.
I can show you my screen.
450. One minute, ma. Okay.
That's what I put in 450 sine 290, and that's what I got. I can put in the cosine too.
One minute, wait. What are we making a mistake on? Hold on, ma. I'm checking. A plane is on a bearing of 200. Okay. Traveling at 450. Mano, are you using the calculator?
Yeah.
What did you get?
Negative 422, negative
You're
1.
using the physical calculator, huh?
Yeah.
Okay, I need to use. Hold on. Are you using the online calculator, Dhwani?
Yeah, just Google. I can get my TI-84.
There I feel like the degrees and radians were mismatching. Let me check, ma. Wait. 450. So simple, right? 450 times cos. Oh my god, my mode and all is not proper. Hold on, guys. My mode is degrees. And then what else I need to say? Mode is in degrees, and then function is a parametric function. Okay, now 450 cos 290. Manav, how did you get that, Manav? Is positive 153 or negative 153, Manav? What is 450 cos 290, Manav? Manav, what did you get? No, this should be both. Okay. Dhwani, definitely for some reason that seems incorrect to me. Okay.
Yeah, I'll just get my TI-84.
Let me as well check because one thing let me show you. Manav's answer seems correct to me for sure. Why, I'll tell you. See, this plane is traveling at a bearing of 200 degree, means it's in this axis. Okay. If it is in this axis, right, automatically it has to be a negative and a negative coordinate. Makes sense. 200 cos, I'm sorry, 450 cos 290. and then 450 sine 290. Manav, what did you get? You got a negative directly?
Yeah.
Where am I missing?
I mean, for my y value, I got a negative two, like for sine.
What did you get? Negative?
Negative 422.86.
Because the velocity plane is a vector. So x component is 450 cos 200. South of west. No? Yeah, this is a negative and a negative vector. Manav, how did you get? What did you put it in, Manav? Did you put 450 cos 290?
I put 200.
But that's the bearing, right? That's not the angle, right, Manav? I feel like Dhwani's answer seems correct now. Advik, what did you get?
I got negative 154, comma, negative 423.
Negative 154, comma, negative. How? What did you put? What were the ones that you put? Did you use the angle as 200?
Yeah.
$200 is measure. Okay. Then in that case, 1 second, guys. No, I have a problem there. Wait. Let me quickly check something. Something is not right. Oh, 1 second, guys. 1 second, guys. 1 second. Sorry, guys. Okay. See, but I need to check something, guys. Hold on. Something feels wrong to me here. Okay. One second, guys. 1 second. Let me check on something. 35 east of north. Hold on. 35 east of north. Na? Wait a moment.
Why'd you make me eat the bell numbers?
35 east of north.
Why is it like that? No, but you made me eat the stupid.
35 east of north. Na?
That was spicy.
Yes. And now my stomach hurts.
Yeah, okay.
No, that's not what happened. Well, what else is on my mind? When I'm not hungry. And I tell her that.
Okay. Akash, how did you do this at school, Akash?
Cool.
Akash, how did you do this at school?
The bearings for us it was completely different.
Means what?
Like, can I draw on the board to explain?
Yeah, please. See, you took 200 or 290 here.
Where we didn't. Okay, let me show you what I did.
You
It
took
was
two.
we didn't do headings and bearings like this at all. We did like just directions. We just figured out how to do directions. And okay, let me just draw. It's kind of so it wasn't even about like this. It was like something else. So it was like let's say let's this is the angle.
Mm-hmm.
It said a ship traveled to this point.
Mm-hmm.
And then they would ask us to make another circle here, and it said from this point it changed their bearing to
Correct,
another
correct. See,
degree.
those are word problems, right?
Yeah, yeah. And then like maybe let's say like ended up here, then you'd have to find the distance and travel.
Yeah, yeah, absolutely. Okay, that those are word problems that come later. But when it came to the basics of vectors, right? How did you express
We
the?
didn't learn vectors yet. We have to start.
Oh, you directly went to word problems, huh?
Yeah, we started to put headings in there.
Oh, okay, okay. See, the way I go, okay, okay, I see. Okay, so only with the, okay, so you always calculated only the angles for the word problems just like that, huh?
Yeah.
Meaning, okay.
Angles, distance.
So you did not learn the component form of a vector.
No,
You
we
did
haven't
not.
even touched vectors yet.
Oh, I see. So you did just the word problems of a ship and a plane, is it?
Yeah. Yeah, that's what we did.
Okay. Okay. Let me come back to this, guys. I have my own question on this. Okay. 450 cost. See, for the plane, for the ships and all, let me come back and how the notation is for the directions alone next week. Okay. I'll stop here and move on to our other. I have my own doubt whether it is 200 or 290 from the x-axis or from the north. If a bearing is given, do you take it from the start as here? I'll check and come back on the notation alone. What angle do we use here? Then that will change the value of the vector as well. So I'll come back to you on this one next week if that's okay with you all. Okay. I'll continue from here the vectors for next week. Okay. Let me do a little bit of graphing on polar coordinates. Does that do good, guys? I'll also verify a couple of places say couple of different things. So let me quickly check on the angle and then come. Okay. Okay. Let's move back to the graphs. Pannu ma, please ma. When I'm taking the class, what is this ma? Okay. So last week we did discuss 4 sin theta, 4 cos theta. So how will the graph for 4 cos theta be, for 4 sin theta be? This was what we left. So 4 cos theta, how did we have the graph? Do you all remember, guys? For the polar graphs.
Priya, do you have some guests over? Is it fine if I leave?
Yes, please.
Thank you.
Do you remember the polar graphs, Krish, Dhwani? Shrag?
Yeah.
Uh-huh.
Yeah.
Okay, so how was the graph, or do you want me to go ahead and re-explain, or do you all remember? You have to let me know. Guys, I want you to tell, right? There is no point in me going on talking. Do you
I
remember?
remember.
You remember? Okay, 4 cos theta. So basically we tape, see, basically this was r will be equal to 4 sin theta. If that is the case, we started a table meaning theta and r. So we started from 0 to pi. Okay, 0, pi by 6, pi by 4. Then we had pi by 3, like that we went on till pi. So 0 we started with a 0, and then like that we went till pi. Pi ended up with a 0 too. So here 4 sin theta, right? So it started with a 0, 2, 3, 4, right? For the polar graph, it started here, and then for pi by 2, right, it went up to 4. So basically the graph came like this. Any questions, guys? Any questions? Any questions? Pi by 6 was 1 by 2, pi by 6 was 1 by 2, and then pi by 4 was it's 1 by 2, pi by 4 was root 2 by 2, pi by 3 was root 3 by 2. So like that it went, and then say similarly on the negative end as well we would have gotten it. It came like this. So minus 4 sin theta graph would be like 1, 2, 3, 4. So minus 4 sin theta graph would be like, it will be on the negative but touching the 4. Any questions? So the cycle was 0 to pi, right? Similarly, here as well, it was 0 to pi. 4 cos theta was this, 4 minus 4 cos theta was this. Any questions on that? Can I move on from here? Okay, how about this? I'm switching completely differently. Hold on. Okay. What did we discuss for the graph? Pi equal to pi, theta will be equal to pi by 3 or r equal to 4. How will the graph look like? How will the graph look like? R will be equal to 4. How will the graph look like? Irrespective of theta, R was equal to 4, right? So what will be the graph? Parvini, do you remember?
Yeah, the r equal to 4 will be a circle on the
Yeah, it will be a circle because irrespective of any value of theta, right? For any value of theta, your r was always 4. So r equal to 4 represents a circle, theta equal to pi by 3. So whatever be the r, theta was always equal to pi by 3. That means what happens here?
It's a line.
Yep, it's a line like this. It will be a line like this. Make sense? Pi, theta will be equal to pi by 3. So that will be a line. This will be a circle. Then the next one. Okay.
Miss Priya?
Yama?
I was a little confused on the limacons and cortisol.
Yes, we'll go there. Right away we'll go. Okay. Now let's go ahead and try this one. How about, you wanted to go to limacons right away? Okay, we can do rose petals later then. Okay, how about we do the graph for this one? We'll do r equal to a plus or minus b cos. R will be equal to a plus or minus b cos theta. R will be equal to a plus or minus b sin theta. These are the different graphs that we are going to see. Okay, linear in a rectangular coordinate, you all know how to graph these graphs. Okay, let's go ahead and try this one. Okay, what did we discuss till now? We discussed r equal to theta graphs. We discussed we did not discuss r equal to theta yet. Okay, we discussed r equal to 3 like that, meaning or theta equal to pi by 3 like that. We discussed graphs. This will be a circle, this will be a straight line. We also discussed r equal to a cos theta, a sin theta. We discussed, and negative of that, minus a cos theta, minus a sin theta. All these graphs we discussed. We drew a table, we put up some values of theta and then found out r, then we plotted, we got a circle, basically a small circle, either either on the right or on the left or on the top or down. Okay, so now we will discuss a plus b sin theta. So here you know this graph, b cos theta graph we just learnt. Okay, now let's go ahead. There can be, meaning a can be greater than b, a can be less than b, a can be equal to b. So let's go ahead and try r equal to 3 plus 3 cos theta. How is the graph going to be? Let me go ahead. So when you think about this graph, right, how is the graph going to be? 3 plus 3 cos theta. In a rectangular coordinate, how will you plot it? 3 will be your midline, up 3, down 3. 3 plus 3 cos theta means 0 is going to start maximum. Then you are going to have pi by 2, pi, 3 pi by 2, and then 2 pi. 2 pi will be the cycle end, right? So what happens here? You're going to start up, going to go down, and then it's going to go like this. So it's going to go like this, right? So in a rectangular coordinate, the midline is going to be 3. This is your midline. This is y equal to 3. So 3 up, 3 down. So this is the rectangular way of plotting 3 plus 3 cos theta. Any questions here? Okay. Now when we go to the polar graphs, right? I want to get a polar graph and show. Let's see. 1 second, guys. Okay, now I will erase the rectangular form. We'll take up a polar graph alone and then we'll graph it there. Let's see this one. Let's take this graph and I'll plot here. I'm going to take this polar graph. I'm going to draw 3 plus 3 cos theta. Now, when theta equal to 0, what happens? Theta, this is R value, right? R equal to 3 plus 3 cos theta. Now, tell me, Parvini, when theta equal to 0, what will be the value of R? When theta will be equal to 0, when theta is 0, R will be equal to 3 plus 3 cos theta. So that would be R will be equal to 3 plus 3 times 1, R will be equal to 6. Right? So 0, 6 is a point. Come to pi by 2. So that would be 3 plus 3 cos pi by 2. So that would be 3. So 0, 3. 1, 2, 3. Now the next one, I'm going to do pi. If I do pi, it will be a minus 1, right? So basically 3 plus 3 cos pi will be equal to 3 plus 3 times minus 1, that will be equal to 0. Now I'll do 3 pi by 2. What is 3 pi by 2? Cos 3 pi by 2, 3 plus 3 cos 3 pi by 2 will end up with 3 plus 0 will be equal to a 3 plus, it will be cos, right? Cos, comma, sine. So it will again be a 3. 3 pi by 2 will again be a 3. 1, 2, 3. Okay, now pi was 0. Okay, when you look at this, this is not enough basically. You need to have more values. So what would I do? I'll insert a pi by 3. Can you tell me what is the value of pi by 3? 3 plus 3 cos pi by 3. What is the answer, ma? 3 plus 3 by 2, right? 3 times 1 by 2 is 3 by 2. So that would be 3 plus 1.5, 4.5. So that would be a 4.5 value on pi by 3. 4.5 means 1, 2, 3, 4, 4.5. Do you see, guys? That is the point. Here as well, it will be on the negative side. 1, 2, 1, 2, 3, 4, 4.5. See, so our graph will go like this. Am I making sense of what I'm doing?
Yeah.
Do you get how you get this graph? You start from here, you go there, and then go back and then come here. These graphs were for a plus b cos theta, right? For this graph, this is on the right side. Whenever you see x-axis symmetrical to the x-axis means it's a cos graph. Okay. Now, how about 3 minus 3 cos theta? How is that going to be? Any thoughts?
Will it just be flipped across the y-axis?
Exactly. It is going to be flipped on the y-axis. So, 1, 2, 3, 4, 5, 6. It's going to be flipped on the y-axis. So, this is going to be like this. So, it's going to be like this. Make sense?
That's pretty.
So, that is 3 minus 3 cos theta. Now, how do you think? See, we are considering graphs of the format a plus or minus b cos theta or a plus or minus b sin theta. Okay. Here we had 3 plus 3 cos theta. We are only considering a is equal to b now. 3 plus 3 cos theta, 3 minus 3 cos theta. So, this is 1, right? This is 3 plus 3 cos theta. Okay. This, I'm sorry. I should not have drawn like that. 3 plus 3 cos theta is, I'll start with 6 here. The two added values, and then here it goes till 3. Here as well it goes till 3. Okay. So this is more of a hearten. That is why it's called as cardioid. These graphs where A equal to B, they are called cardioids. Okay. Now 3, suppose if it is going to be 3 minus 3 cos theta, right? Let me put it in red color. Let me finish with this, guys. 3 minus 3 cos theta is going to be 1, 2, 3, 4, 5, 6. Now this is going to be, till 3. So it's going to go till 3. Here this side is going to go till 6. 1, 2, 3, 4, 5, 6. So it's going to be like this. Any questions?
Miss Priya,
Yama?
don't those have like a loop in them?
A loop?
Like a little circle inside the heart where it connects?
We are only discussing A equal to B, right?
Oh, yeah.
We are only discussing inner loop limicon, you're saying?
Yeah.
Yeah, that comes a little later, right? We are only discussing A equal to B. Now, there are sometimes, okay, now let's say the next thing that we will discuss is A greater than B. So, if this is going to be 5 plus 3 cos theta, next 5 minus 3 cos theta. So, these graphs, we look at it later next week. For now, let's only look at cardioids, okay? Now, this one we discussed both. Now, coming to sin theta graphs, I'll just show you. Then next week, we'll go to GeoGebra and draw and see. Here, suppose we'll consider these two, okay? A plus B sin theta, A minus B sin theta. I said we are only considering A equal to B, and these are all nice graphs, okay? Heart-shaped graphs because they're equal. Let's think about it that way so we don't forget. Now, let's consider 3 plus 3 sin theta. So, when you think about 3 plus 3 sin theta, right? R theta, when you think about this, so it starts with 0 will be a 3, 0 will be a 3. For 0, it's going to be 3. See, that's the point on the graph, okay? 0 is going to be a 3. How about pi by 2? If I say sin pi by 2 is going to be 1, that's going to be a 6. So, 1, 2, 3, 4, 5, 6. Do you see it? So, here it's going to be a minus 3. 1, 2, 3. So, now the graph is going to be like this. Any questions, guys? Pi by 2, pi is going to be a minus 3, and then again pi by 2, pi, yeah, and then do we understand how we go ahead like this?
Yeah.
Again, okay, so again 3 minus 3 sin theta, how is it going to be?
It's just
Next week we'll do it in GeoGebra and see, okay?
It's just reflected.
Yeah, it is just reflected. So that is going to be 1, 2, 3, 4, 5, 6, and then 3 and a 3. But again, it will come to a 0 here. It will be a graph like this. Any questions? Okay, so you can go till 2 pi and see. You can go till 2 pi and see. It will be a 0. It will be a, for 2 pi, it will be a 0. Okay guys, I'll stop here, but next week we'll go ahead with the other graphs. Parvini, you can wait, I'll clarify whatever doubts you have. So we have discussed A sin theta, A cos theta graphs. They're just circles up, down, right, left. And we have discussed A plus or minus B cos theta, A plus or minus B sin theta. Here what is the scenario we have discussed is just A equal to B. I'll stop here guys. Next week we'll go into further graphs and then rate of change of polar graphs. We'll continue vectors too. Okay.
Bye.
Yeah. Bye. Ma.
Bye. Thank you.
Bye, ma. Thank you. Parvini, what is your doubt on?
So like the inner loop graphs, we already did the test, but like I was a little confused because I saw for the A value, some of them, the A value was like the length of like if it was like 2 plus 2 cosine or like.
Shall we take this 5 plus 3 cos theta?
Yeah.
What type of graph is this? 5 plus 3 cos theta. The equal numbers means cardioid, right? Now A is greater than B means what type of a graph? It is a dimple limicon, right? Meaning, Seema, there are only 3 cases, okay? We discussed cardioids, okay? A greater than B is a dimple limicon. Make sense? A less than B is 3 plus 5 sin theta, correct? Cos theta. It's a inner loop limicon. Where are you confused now? This one or this one? You want both?
The second one, the inner loop one.
Oh, inner loop limicon. Okay. Can I go to GeoGebra or you want me to draw it here? How do you want it?
Anything is fine.
Okay, 3 plus 5 sin theta, 3 plus 5 cos theta, right? So I need to share this with you. Okay, let me go here. GeoGebra will go. I don't have that. Oh my gosh. Yeah, I think this one. Yes. So I can do this one, right? 1 plus 2 cos theta, right, ma? That's an example, right?
Yeah.
So do you see?
What I was confused on was how do you find the
how do you graph it? Is that what you're asking?
yeah, no, like,
Seema, 1 plus 2 is what? 3. This is 3. This is 1. You got it? The added value goes to the outer edge. This one of this will come in the inner edge.
Oh, no, because some of the questions from the test, I thought like the A value is what is the length of the inner loop. But some of them were different, so like I was
confused on it. Okay.
Yeah.
See, but 2 minus 1, the difference would be the inner loop. The difference would be the inner loop. Give me one example, or I'll give you one example of that. Hold on. I'll give you one example. Let's see.
Okay.
Okay, 1 plus 3 cos theta is what we did. Yeah, a few minutes, okay. You want, which one you want?
The inner loop.
Inner loop limicon. 5 plus 7 sin theta. Can we try? 5 plus 7 cos theta will try. 5 plus 7 cos theta. How do you think it will come now? I'm thinking, yeah. Let's do it. Let's guess and then we'll do. 5 plus 7 cos theta is towards this side, right? This should be like this graph, right? So this one would be
12.
This one would be
5.
No. You want to check that? No, that won't be 5. That's the problem, I think. You see?
Oh, would it be like
How
you
am
have
I
to
to check?
subtract it?
Wait a minute. How to check? How to bring this smaller? I wish. I don't know. I don't know how to bring
I
this
think you
smaller.
have to click on the full screen icon over there.
Full screen, Amma. Where?
On the bottom right, below the graph.
Yeah. Oh no.
Never mind.
Okay. Okay, 5 plus 7. Okay, now it'll be a 2, ma. See, it shows here, right? Don't worry about it. See, the sum and the difference.
Oh.
You
okay.
got it?
I got it.
Sum and the difference is what the inner loop is.
I thought the inner loop was the A value.
Same thing for the no, it's always the sum and the difference. Same thing for a dimple limicon as well. Suppose if it is 7 plus 5 cos theta, you know what will happen? It will be 12 and then the dimple limicon, right? So that 2 will be like this, meaning it will come like this. You got it? We'll try. I want to see too whether we are saying it correctly. So this is
Because for the other ones, I know the right side goes to
See? Do you see here?
A plus B, and the other one.
Do you see here? Always it's the sum and the difference. Make sense? Dimple means this side too.
Yeah.
Make sense?
Yeah, I understood the dimple one and the
But dimpled one, how did you understand? How did you get the 2? 7 minus 5, right?
Yeah, because I just thought the one with the inner loop would be different.
Oh, inner loop. See, it's always 5 minus 7 here. Okay, 7 plus 5 cos theta is 7 plus 5 cos theta, you will say 5 minus 7, whatever accompanies the cos theta. You see, 5 minus 7 is the dimple here, this distance.
Because the
Okay, this
examples we
distance
were
is 7
given in
plus 5.
class
Huh?
were like the examples we were given in class. It confused me because it all showed like
Oh, it was always 1. Meaning the
Yeah.
difference is 1, and yeah, I got it. It's always the difference, man. Oh, you got it?
yeah, I got it.
Okay, that's it?
Yeah.
Yeah, vector, I'll look at it and come because different places are saying different things. I want to clarify before I come back to you guys. Okay?
Okay.
Bye,
Thank you.
guys. Bye.